Okay, a famous Galaxy radio in SSB mode. The frequency is 28.2 megahertz, as well as the frequency on the generator. We have 1 microvolt set there, and also we have a 10 decibel attenuator. So we will need to recalculate the actual amplitude at the input of the radio. So now let's try to measure the sensitivity. Let's plug in the SINAD meter to the radio. Okay, the SINAD meter should be switched to RMS mode, so we can adjust the output volume of the radio. Okay, minus 10 decibel volts, and then let's go to the SINAD measurement mode. Since SSB is very sensitive to the frequency, we will also need to adjust this fine regulator, fine trimmer for the highest SINAD level. Okay. So we can reach about 4 decibels, but usually they measure sensitivity in SSB mode by getting up to 10 decibels of SINAD. So now I will increase the amplitude of the output signal. Where is the amplitude? Here is the amplitude. Until the SINAD reaches the value of 10 decibels. 10 decibels. I'm increasing, and now I will need to adjust the frequency once again for the maximum value. Oh, it's too much. Okay, decreasing the amplitude. Decreasing the amplitude of the RF signal, and now once again I need to adjust the frequency for the maximum value, maximum value. Maximum value is about 10 decibels. So it shows 2.1 microvolts, and we need to divide this approximately by 3. So we have 0.7 microvolts of the actual sensitivity of this receiver in SSB mode. Now the Galaxy radio is in FM mode. Frequency is the same, 28.2. The deviation is set to 3 kilohertz, and the output signal level is 0.3 microvolts, accounting the 20 decibels of the attenuator. So now we will connect the SINAD meter, and we will check the RMS input level. We'll increase the volume, not too high, not like this. It's like this. Let's switch to the SINAD meter mode, and we already see a SINAD of about 1 decibel here. So we will need to increase the amplitude of the RF signal. Okay, we increasing the amplitude until we reach the value of 12 decibels. 12 decibels. This is what they use for measuring the communications FM receivers. So 12 decibels, around 12 decibels, because it's noise. It is noise, and there never can be exactly 12 decibels. So let's see which it shows 1 microvolt, accounting for the 20 decibels attenuator. So we can see that the sensitivity of this radio in FM mode is about 1 microvolt. Once again, Galaxy radio, and we will now try to measure the total harmonic distortion in FM mode. So for this task, I needed to increase the RF signal as much as possible, so we get a very very clean tone, and the deviation is as always 3 kilohertz in FM mode. So let's now try to connect the SINAD meter. Let's increase the output audio signal so it doesn't go too high, so this level is very good, and we will then switch to THD plus noise meter, and what we see here, it's about 8% of THD plus noise. It's not a hi-fi radio, it's a communications radio, it's an old radio, so THD plus N up to 10%, it's fine for this radio, for this class. Measuring the sensitivity of a broadcasting FM receiver by using a quieting method, 87.5 megahertz on the receiver noise and 87.5 megahertz on the oscillator, on the generator, and minimum output amplitude. So when we increase the amplitude, less noise, less amplitude, more noise, more amplitude, less noise. Okay, so let's decrease the amplitude of the generator to the lowest value and connect the output of the receiver to the SINAD meter, and we'll now switch it to RMS mode and set some RMS level of the noise, it's like 1 decibel volt. So what we need to do right now is to increase the output of the generator until the RMS decreases by 20 decibels. Okay, I am increasing the output of the generator, so the RMS noise at the output of the receiver is decreasing, and it's about minus 19 decibels, so decibel volts, sorry. So it decreased by about 20 decibels, and the output level at the output of the generators is 33 microvolts. This is the sensitivity of this nice LG receiver.